Hello, this is how to create an engineering drawing or model from a 2D based drawing which is quite cluttered and not to the correct BS8888 standard. So just going to show you our model. So this is our model, which is a component off of a vice system. Particular component bolts using 3 fasteners on a 30-degree angle onto a secondary system, and then has a threaded hole through the top for a handle and screw. So this particular component hasn't been laid out within the best way. So essentially this component here is the front view. Okay, this component here is the top view, and this component here is the side view looking at this way. So essentially what we should have is a front section here, a side section there, and a top section looking down. So this particular view should be in line like so. So we should have our top, our front, and then our side. So what we're going to do is we're going to change this drawing, which is not correctly laid out, into our next component. So to make my life easier, what I'm going to do is I'm going to draw all of the necessary information where I need it. So first stage is I'm going to focus on the top and the front. So quite simply, all I'm going to do is draw a square to simulate my top, just really basic drawing. Here. So there's the top. I'm just going to draw my front view now. Like so, and now I'm just going to draw my side view. Very straightforward. In a second, I'm just going to jot down all the key bits of information so I can start the next process. So what we know is that here to here is 35, so we know we've got that dimension. We know that here to here is 20.65, so with that dimension there. We know that there to there is 24, and there to down there is 24. The centre of my hole is 12.65. Okay, we know that that component there is 35 as well. So this component here is 10, which actually relates to this component here, so this part is also 10, and that makes that part 10, and the middle bit is 15. We know that this part here is 25.5, and the overall height is 50. We have to be careful of in this drawing is when you zoom in, it's like this 24 here, and that line there is actually 0.5 mil gap between the two. So 25 is and then 24 obviously only make 49.9. So okay, so we've got those dimensions there. Just going to go back, just going to look at this additional side view here. So we know that the whole here is an M12 1.75. So essentially that's C. There it is going to be M12 by 1.75, and the whole inner is going to be 10.2. Because that's the size for an M12 for the drill size. We know that from the left hand edge to the centre 17.5. The top down is going to be 12.5. So we have those two and the thread. Okay, last one is we know that that is all on a 30-degree line there, which we're happy with. This point to this point is 25. Okay, and then we obviously have M8 times 1.25. And then we have CSK11 to Celtic 11, and then a 6 diameter in the centre, so we're happy with that. Okay, so that's our drawing complete. So obviously I've split it all onto TVs, but hopefully that should aid my my drawing skills a lot easier now. So okay, so I've now opened up Fusion 360. So I'm on the home screen. So I haven't saved my part yet, which I can do at the end, or you can do it at the start. Just hit the save file. I know I'm in the design workspace. Again, I've got my toolbar on the top, and obviously my orientation on the front. So just obviously a recap. We're obviously going to make this component, which we've done a cluttered 2D into a sketch to make it slightly easier for us to process. I quickly drew it out a second ago in this format, which for me makes sense, but for you guys I'll keep referencing this one because it's a bit more clearer. So essentially we're going to start to build on our faces, so front face, top face, side face, and we're going to build our components. So you need to remember the key measurements it's 35 square by 50 high, so that's the first part that I'm going to do. So I'm going to draw my block of material first. I'm going to draw on the front face here. So we use the rectangle function now. So it's obviously going to be 35 by 50. Okay, just the other way around, 35, that's my front. Finish that sketch, and now I'm going to extrude that by 35. So that's my profile. The other way that you could do it is draw it out and then extend it out as well. I'm going to show you a couple of ways. So this is called the subtractive method, where we're removing away from our material. So on my front of my sketch, okay, I'm quite simply going to create a new sketch. I'm going to cut away that first part from here. So remember it was 25.5 and it was 20.65. So there's my two measurements. I'm just going to quickly recheck. So I've got 25.5 there and 20.65, 20.55. Yep, so I'm happy with that rectangle. And I'm going to use the cutaway feature here. So I'm going to do a cut, and it's going to be through all, and just going to flip it around, so it's going to remove, like so. So there's my cut on my front of my plane, like so. Now I can use the chamfer tool in the system. So I'm going to draw it out. I'm just going to put a chamfer on this face and this face, which is the 10 mil, like so. And now I need to put a chamfer again on this edge, which is then 24 millimeters, like so. So that's my main part of my shape done. Flip round to the back edge here. I'm going to put a hole in. So I'm going to choose this surface feature here. Now I need to choose a couple of reference points. That's my first reference, which is, we know is 12.5. My second reference, which is going to be the left hand side, which we know is 17.5. That puts my hole in the center. Now I did actually click it too early, so I'm going to right click the hole, edit feature, change it again. So this time I need a tapped hole. It's going to be through all, and it's a 12 by 1.75, which I'm happy with. I'm just going to edit the feature because it's a through hole number, so it's got to go through the whole material, like so. There's my thread hole there, showing quite nicely. Now, when we draw it on the other side, we can now draw it on our left-hand feature. So to make it nice and easy, I'm actually going to draw a sketch of it first. So I'm going to draw a couple of points where I can. So I'm going to come down and create, choose point. Once I've created my sketch, come down, find a point function, place 1 point. Okay, now I'm going to offset that 1 point, so obviously from the left, you know, it's 17.5, and then the height. This is what I need to double check. So the height for my point is 12.65. So it's clearly shown there, 12.65. So 12.65 is going in. That's my first point. Next part is obviously I need to draw that midpoint line. Now, when we go to line, there is really no sort of midpoint function. So I'm going to place my first point. So it's 25.1 because it's 12.5, and then I'm just going to draw another line the other way, 12.5. What I can do is I can then rotate. If I move or copy, select both of your lines, hit the rotate function. Okay, I'm just going to put 30 degrees in. So just make sure, so selection is these two, and then my axis is going to be on the bottom, 30 degrees. It doesn't want my axis. So what I could do actually is just put a quick, put a quick 25 mil damming, so it would just help me select the axis. I didn't like my axis for some strange reason there. Rotate, my axis is going to be a circle. .30 degrees. I'm just going to go back to my drawing 30, which is the correct way, and tick that off. So that's my sketch there, which I'm happy. So that's my sketch. Now I can come onto the hole feature. I know that the first hole I can pick it on the center view. So the first reference to my center point, like so. This is going to be through all again, and if you remember rightly, this was an M8, so 8 mil hole, animate 1.25, okay that. We'll come back into the whole feature again. This time we're not selecting these two, 1 and 2. This time it's a countersink hole with no thread. So got countersink coming through all again. Top is going to be 11mm. The bottom, if you remember, was 6mm, like so. One sketch. Okay, doesn't like me 11mm. Countersink we have through all distance. We have 11mm. Then we have 6mm there. Okay, I might have to just not like them a whole size. Okay, so something wrong with my sketch there. Okay, so that's definitely correct. I'm going to come back again. The distance is through all, so countersink, 6mm, 11mm, 1. 1, 2, like so, and conjunct. Sometimes the system just it picks up different areas of your part, so you can make sure you are continuously. So we have to cancel and reinsert. And so there's my component, which is fine. So we can save this now. We can save this into, so it's my vice block. I'm just going to save it into a new folder. So just going to call this vice clamp, which is what the big of this component will be. Save. So now we can come off of the design workspace into our drawing workspace. Now, there is one thing you can do beforehand, is when you go to your preferences under your name. Okay, when you come down to design, a couple of things you need to obviously make sure before we go into the drawing tab is that standards you can inherit from the design, or you can just sort of select for you. So I live in the UK, so I'm always going to use ISO. Units are going to be inherit from the design, because sometimes I do inch. So we use third angle, so you can actually change the text height if you want, font, So all these areas in here is under preferences, which will be under your account, and then you can obviously apply and then OK. Make sure you do that before you go into the drawing. So now I can go into the drawing workspace from design, full assembly, create from scratch, template ISO A3, which I'm happy with. This one I convert into a drawing now, which I can now edit and set up correctly. So this is obviously my view. So it's putting some components for me already. So drawing view. So I can place my base view, which I can say is my drawing, so I can sort of put it on the component. This is at 1:1 scale. I could actually sort of say I want 2:1 scale maybe. See if I can fit it in. Standard size to show the visible edges, visible and hidden, shaded, or shaded with edges. If visible with heads. So it'll come to that view there, which I'm happy with. And we can do a projected view off of this view, which will be my top. Like so. Happy with that one. Which is fine now. So obviously that one, I thought I clicked a bit too early. So again, just use that space. Make sure you've got enough room to manipulate your component around. So that should be enough room for me to put all my symbols on. So what we have here then is obviously the move function, rotate. These are your views. You've got detail views, section views. So I could actually say I want a detailed view of my view here. So I could come in and say I want a parent view of all of this, and then do a lot more detailed view about here if I find it necessary. I could do a whole detailed view there. At 4:1 scale, which again is pretty big. But if you're doing a lot of 1:1 scale stuff, sometimes having these additional views is quite handy, but I'm not going to use one of these today. And obviously if I did a section view as well, I could do a section of just do like a section of my component, for instance. But again, I don't need any of that. It's quite a simple drawing. So modify geometry aspects, and I have my dimensions here. So our ordinate dimensions or normal dimensions, or I can just drop down the list and have some standard ones. So again, I'm just gonna run through really. So I know it's going to be 50mm high, so I'm going to start up here, 50mm. So I'm going to put the 35s on this view because again it's easier to get it out of the way. I do try and keep them a bit standardised sizing if I can. That edge to that edge is sometimes quite important. This one, my 35 is going to be in the way really. Centre mark my middle. So again, just it splits in linear. I've got a bit more control then. $17.5. By 12.5, so I give you my edges, which are cool. Again, so like AutoCAD, you can actually move these up and out of your snap points. He says, if not, I might have to do like a trim, just sort of trim them down. Because really, you don't really want any of your parts way off your drawing like that, really. You really want them out of the way. So I've also got like diameters as well, and also have this other one called hole and thread callout. So if I choose click on this hole, I can choose a point Now tell me it's an M12 times 1.756H. Likewise, I could do the same down here. I could do a whole call out for all of my components. It just makes it look a bit more professional. Again, don't be scared to move stuff around so it looks smarter. That's what we always try and do, make a nice, smart, professional drawing. Last one I do, I just need to do there to there. So it's just a shame I haven't really got the manipulability like what you do in AutoCAD, really, where you can actually just manipulate these. Which is probably bit of a shame, but it's fine. It'll still pass as a drawing. I'm just going to maybe I can click move. No, let me move them. That's a shame. So again, I've got all my components. 15. Just need to put the 24 in. Again, just make sure we're clicking on the right component. Last one, I got the 11. We can match them up as well, make them nice. Now I'm just going to come down to the last one. I just need to put a small little bit of center marking if you wanted to. I can say, well, this to the bottom, 12.6, this to 17.5, point to point. If I did an angled one, and then I could do an angle as well. So just draw a center line in. I could sort of just put a sketch line in here. Finish a sketch, and then I can put a dimensional angle. Like so. There's all my component done, and I can just come on now, double click, I can then come in, call it VB001. Okay, remember part. Uh, 16th, 11th, 2020. Like so, technical reference, eng, VB01, department, eng again, that's my drawing then complete. And then again, you can just output it or save it. So you can then go to a print to PDF, and then it's job done. Okay, thanks for listening.